given this question, we expected to evaluate 2 over pi integral negative pi over 4 to pi over 4 dx over 1 positive e raised to the power of sin x times 2 negative cos 2x. I've already mentioned to you how to get rid of this 1 positive e raised to the power of sin x. So this would in turn result in us multiplying the entire integral with 1 over 2 followed by 2 over pi integral negative pi over 4 to pi over 4 of dx over this is neutralized, and because of this being neutralized I'm getting 1 over 2 here. So all that remains is 2 negative cos 2x. Now I can clearly cancel the 2 here, so that is going to give me 1 over pi integral. Now negative pi over 4 to pi over 4 of 1 over 2 negative cos 2x. Clearly this is an even function, so I can write this as 2 times, right? So 2 times of 0 to pi over 4 dx over 2 negative cos 2x. Now we know a formula. What is that? Cos 2x is equal to cos squared x negative sin squared x. But cos squared x, I'm going to retain cos squared x as it is, but I will retain, or I should say I will rewrite sin squared x as 1 negative cos squared x. So this is going to be equal to cos squared x negative 1 positive cos squared x. I can add these two to give cos squared x with the 2 being multiplied there, followed by a negative 1. So what is this? This is my cos 2x. So hence I can rewrite this integral as 2 over pi integral 0 to pi over 4 dx over 2 negative of 2 times of cos squared x negative 1. Now what I wish to do is, okay, first let me simplify the denominator. So this is 2 over pi integral 0 to pi over 4 dx over 2 negative times negative 1 is positive 1 followed by negative 2 times cos squared x. So this is equal to 2 over pi integral 0 to pi over 4 dx over 2 added with 1 would give us 3 followed by negative 2 times cos squared x. Now what I wish to do here is I'm going to multiply the numerator and denominator by secant squared x. So this is going to be 2 over pi integral 0 to pi over 4 secant squared x in the numerator divided by 3 negative 2 times cos squared x times secant squared x in the denominator. So this is equal to, I will distribute secant squared x in the denominator. So this is 2 over pi integral 0 to pi over 4 secant squared x times dx divided by 3 times secant squared x followed by negative 2 times cos squared x times secant squared x. Now we know that secant squared x is 1 over cos squared x, right? So therefore cos squared x times secant squared x is equal to 1. So this is equal to 2 over pi integral 0 to pi over 4 secant squared x dx divided by 3 times secant squared x negative 2. Now we know a formula, secant squared x negative tan squared x is equal to 1. So secant squared x is rewritten as 1 positive tan squared x. This is always possible. So I'm going to use this result over here. So this is going to be 2 over pi integral 0 to pi over 4 secant squared x dx divided by 3 times of 1 positive tan squared x negative 2. So this can be further rewritten as 2 over pi integral 0 to pi over 4 secant squared x times dx divided by 3 times 1 positive 3 times tan squared x negative 2, which is equal to 2 over pi integral 0 to pi over 4 secant squared x dx divided by 3 added with negative 2 would give me 1 positive 3 times tan squared x. Now I wish to make the following substitution. So I'm going to say let tan x be equal to t. Differentiating, I get secant squared x dx is equal to dt. So this is equal to 2 over pi. I'm not going to touch the limits as now. So secant squared x dx is going to be dt divided by 1 positive 3 times tan x is t. So it's going to be t squared. Now the limits, let me just change the limits. So now when x is equal to 0, t will be equal to 0. When x is equal to pi over 4, t will be equal to 1. So this is going to be 0 to 1. I can rewrite the integral as 2 over pi integral. I wish to take 3 out. So if I were to take 3 out, this is going to be t squared positive 1 over 3. Now let me rewrite this as follows. So 2 over 3 times pi integral dt over the limits are 0 to 1. This is divided by t squared positive 1 over root of 3 raised to the power of 2. I can rewrite 1 over 3 as 1 over root 3 raised to the power of 2. Now we know that integral dx over x squared positive a squared is 1 over a tan inverse of x over a positive c, right? So if I were to use this formula, this is going to be equal to 2 over 3 times pi 1 over a times tan inverse of x over a. Of course the limits are 0 to 1. So this is going to be, I'm going to push this off to the numerator, 2 times root of 3 divided by 3 times pi tan inverse of root of 3 times t, limits are 0 to 1. I substitute the upper limit minus the lower limit, so this is going to be 2 times root of 3 divided by 3 pi. When I substitute the upper limit, I get tan inverse of root 3 followed by tan inverse of root 3 times 0. So this one goes off. This one would give us, let me write that down, 2 times root 3 over 3 pi. This is going to be pi over 3. So I can cancel the pi's here and I can rewrite this as 2 times root of 3 divided by 3 multiplied with 3 gives me 9 units. So that would be the solution for this question.